G'day, how's it going? Mr. Fitz here. Hope you guys are doing well. This is a Dirty Fitz production. Welcome to our series on CAD. This series is designed to help you learn about CAD and become a master at using it. This video in particular is an introduction to CAD, why do we need to learn it, and some of the basic structures to get you underway. So CAD stands for Computer Aided Design, and essentially it is a software, it is a tool for designing products, engineering solutions, and basically anything that you could come up with as a design. It can be modeled in CAD and used as a form of manufacturing or for communication of your ideas. You'll also see other terminology used. So CAM stands for Computer Aided Manufacturing, and this is combined with CAD in order for you to take your designs into manufacturing. Around the school and other areas, we have machines that are what we call CNC machines, which means that they are numerically controlled. Essentially, just takes numbers and information from a CAD program, so a model or a design that you've created, and uses that as information to manufacture. So it could be for a machining process. Additive manufacturing is another term you may use or hear, and that's particularly looking at new modern technologies and things like 3D printing. Now, CAD is a very general word. There are hundreds, if not more, of different CAD programs that often have a purpose or an application that's useful. Essentially, CAD overall is just a design tool. These top three programs here you may have seen or have some familiarity with. We've used Inventor for a number of years at our school, but are now transitioning to the software called SolidWorks, which is based on our computer suites. It's a very advanced industry level software that has a lot of functions, and also the software OnShape. This video series we're going to be primarily looking at OnShape, but there's a lot of similarities between OnShape and SolidWorks. So once you learn one, your skills are quite transferable. The beauty of OnShape is that it can be run via an internet browser and doesn't require a very advanced computer to run it, whereas SolidWorks, on the other hand, is a bit more intense. These software that we're looking at are what we call parametric modeling programs. Parametric meaning that when you design, you've got to include measurements and dimensions and information that defines your design. And in conjunction with that, as you start designing your product, you're able to go back into history, the history of your design, and make changes. So everything is editable and is very intelligent as we go. The main applications for these software is consumer product design, but also there's other industries, mechanical manufacturing engineering, automotive, aerospace, defense, and industrial. So very broad applications of this software. And essentially, if you can learn some of these software, it can set you up to work in any of these industries as an engineer or a designer, or even just to understand how it works if you work in any part of these industries. Here are some image examples. This one's out of SolidWorks. So this was a piece of earth moving equipment designed entirely with CAD. So designers and engineers collaborate to model all the parts of it. They can simulate it and they can design and manufacture this from CAD. Here's a snow making machine, so you can see all the parts again are all modeled and assembled. Aerospace industry, every plane that you fly in today would have been 100% modeled in CAD. It can be tested and verified before it's manufactured. It's very powerful. Here's some consumer product design. In particular, this is a piece of equipment that enables some mobility and tracking of your mobility. So very useful in consumer product design that you can simulate how something's going to fit and work. Aerospace, 100% new technology is all designed using CAD. And also every car that's driven, every part of the car would have been designed and modeled in CAD before it was made. Consumer product design, phones, prime example, anything that you consume today, consumer products, I guarantee would have been designed and modeled at some stage in CAD. This is what we call a rendering that shows you a graphical representation of what the thing will look like before it's made. So CAD is the core of advanced manufacturing. We'll fly through this quickly. Essentially, it all begins with a part file. So you will model up a part. That can then be converted into a drawing, some other file format, or a CAM file. These carry through to production processes like laser cutting, to 3D printing, and to CNC machining. So the information we generate here can flow through to these processes. So very intelligent. In addition, most things that we consume today are still manufactured using traditional manufacturing methods, but we can still generate information from our designs that are used by tool makers, production technicians, manufacturing people to produce what we are after as a design. So we can create a drawing, as you see here. That's all created from CAD. A few other applications for CAD. As you saw before, we can create photorealistic renderings, so images that are used in marketing and promotion. You can make some stuff look pretty fantastic in CAD. This very closely links to some of you that might have some experience in things like modeling for gaming. CAD is very much a software that you can go into that pathway as well. We can create animations, so you can make things come together and go apart. You can do fly-throughs. So it's very useful for communicating information and marketing purposes. And most powerfully here on the right is CAD is very useful for engineering. So we can actually put a plane in an environment. We can look at how it flows through the air. We can have a look at stresses and structural issues. And essentially we can design a superior product way before we ever manufacture it. So we can confirm and use it as a method of um, like simulating and confirming if it's going to work or not. This is the general file structure for CAD. So this does differ between programs, but OnShape and SolidWorks uses the format where you always begin by designing a part. So think of it as something like a general product that you use. It's made up of lots of components, but we start by designing a part. Now that part can be taken into an assembly. So when you've got more than one part, you can build an assembly. And then across the side here, we can also create a drawing. So as I showed you before, this is where we add in technical information and represent our designs on two-dimensional drawing paper. So we can print it, we can give that to people for manufacturing. And that's the general structure. So this is the basis of understanding how we use CAD. This here is what we call a basic model flow. We'll refer to this a bit in our videos, but it's really interesting to understand that once you wrap your head around this process, this is very much the same for all CAD programs. So at the start of anything we design, we must create what's called a 2D sketch. So a sketch is just a profile, a closed loop that we draw on a face or a plane in our modeling area. We can then take that profile and we can turn it into a solid. So we can make it a solid three-dimensional block, or we can spin it around an axis and create a revolved geometry. We can then also use the same process to cut and remove from our models. And then there are other more advanced things here where we can create more advanced geometry in our program. Over the side here, we can take our solids and we can round corners, we can cut off corners, we can create patterns of features and mirror features. So the next series of videos, you're going to learn this whole structure here of how we design and use these tools. What I have put here is essentially the small icons here are all the ones from OnShape. So they're taken straight out of the program. The larger ones are taken from SolidWorks. So there might be a bit of confusion here with the number of icons, but this will make more sense as we go. So why do we want to learn CAD? CAD is the basis of designing solutions to problems and opportunities. So much in our world today, we've got to design solutions to problems. That's a lot about what we learn in technology as a learning area, as well as entrepreneurial learning. We need to find solutions to problems. We can start by creating sketches and concepting, which a lot of you will be familiar with. But essentially, we go as the next level into CAD to bring your ideas to life. So you can start seeing them three-dimensionally and how they take shape. From there, we can prototype, we can build, we can communicate your ideas. So it's a very, very useful tool. and essentially change your world. If everyone learns a bit of CAD, they will be able to design basic things in their household, and then become designers and engineers themselves. Skills are very transferable. Once you learn the basics of CAD, it actually helps you with your maths as well. There's a lot of maths involved and numeracy, but it also helps you visualize things in 3 dimensions. So it helps your spatial concept, and these skills are very transferable into a lot of other learning areas. Huge career potential. There are so many job opportunities moving forward, in designing, engineering, and problem solving. And if you've got some basics in CAD, it's a very useful tool that you can add to your resume, and can get you into different careers in this field. Thanks very much for watching the introduction. Please stay tuned to some more videos from Mr. Durst and Mr. Fitz. Thanks, everyone. Have a great one.